All right, hello again. All right, here we are. I am about to record a video on function inverses. Now, this I kind of foresee as I was preparing for this video, I kind of foresee this to be a very long video. Possibly should be broken up into two pieces. However, it depends on how it's going. So this last, here's what I intend to go through. Um, the idea and the notation of what a function inverse is and how to write it, the actual procedure of finding inverse functions, and I will use a variety of different types of functions as examples. I will also I would like to get to the important property of how functions and inverses are related to each other. And lastly, and it's very possible that this I may not be, it may not make it into this video, but maybe a second part of this video or a second video, the graphical approach to it or graphical representation of function and its inverses. Now, this topic could be in an Algebra 2 class, especially like an honors Algebra 2 class or a typical pre-calculus class. Where this is useful is really throughout. Inverses are useful throughout the more advanced, beyond Algebra 2 maths. Definitely in calculus. And okay, so let us start. So I'll do it right here. What is the idea? It's basically having a function and another function, and they're inverses of each other if they undo each other. So as an example, if f function does something, and we'll do the examples in the next page as the actual what f does. So this is some kind of rule that operates on letter x or operates on something on theoretically an expression. However, and whatever that is. However, there is another function that a g function, we'll call it for a second, which undoes everything this does to begin with. So this does something, and this one undoes something. So it's gonna feel very similar to solving an equation, because when you're solving an equation, you do inverse operations and so forth, and that's where the word actually inverse actually comes in here, because you're doing opposite of what the original function does. Now, as far as notation, there's different notations. I could call, if as an example, f function and g functions are inverses of each other, well, I could call them that as such, right? Like f and g and so forth. But I can also say, well, if f and g are inverses of each other, then I could call g function by this notation. F inverse. Now, this is not an exponent. This is not 1 divided by f of x, just be very clear. This is just this kind of goes together. And we could say that, f inverse. When you get to trig, there's a slightly different way of, old-fashioned way of writing inverses as well for trig functions. But, and I may not explore that in this video, because I definitely want to introduce trigonometry in here, even though in Algebra 2 and you may not have had trig functions yet, but that's okay. Anyway, so the notation could be either f and g, and they literally say f and g are inverses of each other, or more typical, they'll say here is given an f function, find its inverse. In other words, they want, given this, they want f inverse of x. Okay, that's the question. Okay, so the notation, right there is f inverse. Let's actually do the procedure, or talk about the procedure. You're undoing whatever the original function is, and maybe I should actually do a demonstration. Yeah, might as well. I'll just do it very quick. So let's say we have a very simple function, because it starts off as f of x equals, let's say, 3x plus 5. Really, really simple. Linear function and so forth. So you can picture it, what it looks like on a graph. And I want to undo it. I want to find the inverse function. Well, the procedure is the following. So first step, and typically I call it rename f of x or g of x, whatever this is, in rename for temporarily, rename f of x into y. It's really just for convenience sake. It's really not 100% mandatory, but it's just literally, like I said, it's convenient. So that's the first step. The second step, and these could be combined. There's no rule saying, oh, this must be the first steps. I mean, this is, one follows the other one. You switch, okay, misspelled. Switch x's and y positions. And actually, positions. Actually, the moment that you do that, you are already creating, you just created f inverse. You created the function inverse. Now, so in this case, let's actually do it. So this is, I'm going to rename this as a y. So this is y equals to this. More, that's familiar to, especially from Algebra 1, coming out from Algebra 1. So I'm going to change my x and y positions, and this is going to be x equals 3, y plus 5. So that's my second step. My third step is actually solve for the y value. Y equals for here. But honestly, right at this point, you already created, just by switching the x and y positions, you created the inverse function. It's just that we typically, when we write a function, we write y equals or f of x equals, but we don't write x equals in terms of y. All right, anyway, let's continue. So I'm solving, using algebraic steps, solving for y. Obviously, you subtract 5 from both sides, and then you divide it by 3. So if I do this, x on the other side minus 5, and you can write it like this, divided by 3. Or you can just separate that and say, well, this is like 1/3 x minus 5 over 3. It's same thing. And we're like 99% done. So the only thing I want to do here, number 4, is rename it back, because this y was temporary, just for convenience sake. We're going to rename the y back into the original letter. Oh, I didn't mean that. Into the original letter, which is f letter, but we can't really call it f of x equals 1/3 x minus 5 over 3, or this version. It doesn't matter. Here I'm writing this in y, as in y equals mx plus b format. We really can't call it that because f of x is already spoken for, but we indicate that f, this is an inverse, and we indicate with like a -1 here. Looks like an exponent, but it's not. This is a symbol that goes together. This goes together. And if from here, the original function was f of x. The y was just temporary because it's just easier to switch the positions x and y as opposed to x and f of x, or whatever that letter could be a different letter instead of just f, could be g, and so forth. All right, so let's you could pause, you could take notes on this, and here is the actual like the logic of it, the procedure. But through a couple of examples, you should be okay. So let's do a couple of examples, and I'll do a variety of examples so that you're more familiar with different types of functions as doing inverses. So in the first case here, this is a linear function. I could see that, even though it's written like this, but I could theoretically rewrite this as a y equals mx plus b. But anyway, this is a linear function. So will I have enough space here? Well, I might have to use space and actually erase between. Yeah, I should have made myself a little bit more space. So anyway, so what's the first step? Well, the first step, I'm going to rename this temporarily into like the letter y. And in this case, it started off with G instead of F. It doesn't matter, So now I'm going to switch their their x and y positions, and I'm going to rewrite it over here. So this is going to be x equals negative 3y plus 15 divided by 2. Okay, what's my next step? Well, I'm solving for y. That's all I'm doing at this point. I got to get y by itself. And the normal operations here, you multiply by 2 both sides, and then I'm going to subtract 15. Hopefully you could see that. And then divide it by negative 3. And that'll be my answer, because this is 2 or 3 step linear equation. All right, but so anyway, the first step is multiply both sides by 2. This is gone, so you have 2x, and it's gone from here, minus 15 equals negative 3y. I could, and the following step is divide both sides by negative 3, and the y will be by itself. So I'm going to rewrite y equals, divide both sides by negative 3. And I could leave it like this, like 2x minus 15 divided by negative 3. That's perfectly okay. Or I could separate them into y equals mx plus b format, and I'll do both just so that you're aware you could do this. Okay, anyway, so this is like 2/3 x, so my new slope is negative 2/3. And over here I have negative 15 divided by negative 3, which is plus 5. So notice y equals this, right? This is my function inverse from the original letter g. So I'm going to rename it over here g inverse of x. And so putting this together, kind of like you could skip the middle part or not. I mean, hopefully you see it straight through. This is the notation for it, but this is the actual inverse of this. And if you look a little closer, a little more carefully, you can see the similarities where you undo something by something. Yeah, as an example, here x was getting multiplied by 3, technically by negative 3, and here it's being divided by 3. Anyway, so I'm not going to go through the like the similarities, but that was that's the answer. So I'm gonna jump to the next one. I'll try to do a variety of these problems. Let me see. Actually, let me move this. Sorry. Yeah, let me move that little bit out of the way. Okay. All right, next one. This one right here. So try to recall what the procedure is. I'm just going to go through it pretty quick. Well, this is a cubic function right there. So this is a polynomial function. So I mean, I already pretty much see my answer because it's just a couple of steps away. I'm going to rename this into a y and then switch the positions right away. So this is going to be x here equals negative 2 plus y minus 1 to the third. Okay, again, I renamed this into letter y right here and then switched from here to here. So here it is. And now I'm trying to solve for y. I want to get y equals. Well, what's the first step? Add 2 to both sides, take a cube root, I see, and then add 1 at the end. So I'll do that pretty quickly. Y, if this is too quick, I mean, slow down and rewrite just for space wise. You know what? No, I'm going to try to fit that in case I'm going to lose somebody. So first step is add 2 to both sides and then take cube root. So this is x plus 2, cube root it. What's left on this side? Y minus 1. And I'm adding 1 to both sides. And in the process, I'm going to change their position. We typically write y equals first. So this is going to be y equals cube root of, that's a cube root of x plus 2 and then plus 1. And as a final step, I'm going to rename it back into letter G, but I can't just say G, this is G inverse. So there is my final answer. So let me see, let me highlight this, final answer. And so this function right here is the inverse of this. And in this case, you can actually very, very clearly see how they interact. So like as an example, for the original function, I have a, right there, cube. So I'm expecting to see a cube root because that's the inverse operation. Over here, I'm seeing -1, and somewhere in here, I see a +1. Okay, same thing here, as I have a -2 here, and I have a +2 in here. Okay, that's not the best way. You can't just look at this and say, I'm going to rearrange it randomly just using these you know, these digits or these values. But there's a logic to it. Okay, so I'm going to pick up the pace at this point. Yeah, I should have put a little more space in between. Anyway, so I keep moving this thing. Nope, not this. My screen. Okay. This. So looking at this, this is some kind of fifth root function. Okay. So this is y equals. I'm going to in one step rename this and move the x's and y's. So this is x out here equals big root, fifth root, and what's in here is negative y minus 3 divided by 2. And now doing the order of operations properly, I'm going to fifth power both sides. That's going to get rid of this fifth root. Then I'm going to multiply by 2, and then I'm going to add 3, and then I'm going to multiply by -1, all of that. So just by looking at looking a little bit ahead. So in fact, for the space sake, I might actually just do the whole thing in my head. So this is going to be, well, let's do it, x to the fifth power. Then I'm going to multiply it by 2, so 2 in front. I'm going to add 3, and then I'm going to multiply by -1, kind of like this, the whole side, -1, and that equals to y, and that's, so I'm gonna recopy it a little cleaner over here. Y, well, I'm gonna also, in the process of switch it back to the letter f, f inverse of x will be -2 x to the fifth minus 3. There is my final answer. And if you look a little closer, you'll see similarities. Where the similarities kind of end. This is -3 here, and this is -3. So you think, oh, this should be a +3. Yeah, yes, that would be true if what screws things up is this minus in front. You really can't just well, you can if you look a little deeper, but on the first glance, you might be like, oh, I have a -3 here. I should be anticipating seeing a +3 here, and that would be true if this was not here. Okay. All right, so there is my inverse of the original function. So I think this is going to be very, very similar. In fact, I'm going to, just by looking at it, I'll be able to actually do it. So this is going to be, and see if you can follow. If you can't, just pause, do it, and then compare my answer to yours. Hopefully, we're both correct. So this is going to be my x. When I switch the positions, times 2 and plus 6. So this is 2x plus 6. And then I'm going to cube root, not cube root, opposite of, so this is to the third power. And then divided by 4. And there is my y equals. Or the original letter is f. So this is f inverse of x. This is my final answer right here. The original problem was a cube root problem. The inverse of it will be something cubed. Okay, All right, the last two problems are probably a little more challenging for most students. Not that the other ones, well, I mean, the other ones should not be challenging, but anytime you have a rational function, it actually, well, in this case, it may get little bit more confused. This one's not. In fact, I don't think this one. I don't think I want to do. It's too simple. This is a linear function. If you separate that is simply 2x over 3 minus 2/3, which is very similar to, like, I think what I did. No, no. Okay, it looks okay, but I don't know. It's a pretty simple function. So you multiply by 3 here, and then you add 2, and then you divide by 2. Okay, whatever. All right, this one's a little bit more challenging right here, because you have x in the denominator of this function, and it's not just simple x; it's x minus 1. Anyway, so you'll see in a second. All right, so how do I start? Well, again, we're going to rename this into a y and switch their positions right away. So let's do it. So I'm going to switch the position. So this is y, but then when you switch x's and y's, x is going to be out here, equals -3, and this is going to be y minus 1 plus 1. So anyway, all I did was I made this into a y, and then I switch my x's and y's. Okay, now we're going to solve for this y. And so what are my steps? Okay, well, subtract 1 from both sides to get rid of this. This is x minus 1. I mean, I can see what my answer will be, but I need to, I'll show you one step at a time. So this is, what's on this side? Well, -3 y minus 1. Now, how do I bring this y up top? Well, you can't just bring up the y. This is like this is a fact. I mean, together, this denominator is one number, if you will. It's an expression, yes, but you can't just bring up the y. So what I'm going to do is I'm going to multiply both left and right side by y minus 1, and at the same time, I'm going to divide both sides by x minus 1. Now, you could pause and replay what I just said. Well, I guess I could actually do it, right, for that matter. So I'm going to multiply both sides by y minus 1 on both sides. So this is y minus 1, in parentheses, y minus 1. But make sure, okay, on this side, by the way, right, what happens on this side? Well, they cancel. Okay, that was the goal, really, to get it out of the denominator. But make sure at this point you do not FOIL this out. You do not distribute. We do not want to complicate, now have a combination of x's times y together. Absolutely not. Right now we have only one appearance of y, which is nice. How do I get rid of this x minus 1? We'll literally divide both sides by this x minus 1 as a parenthesis. And this is going to become, and I'm going to show my work, y minus 1. You can put parentheses if you wish, but this cancels, equals -3 divided by x minus 1. I'm dividing both sides by this, so you could think of it sort of like this. And on this side, x minus 1. I'm dividing both sides by this. These canceled. On this side, this cancels, leaving you with y minus 1. Okay, that's almost, almost there. Just an extra that would get rid of this. But on this side, this is what I get. And as a final step, clearly I add 1 to both sides, and it's gone from here. And this is my answer. This is my inverse, inverse function. So I'm going to rename it back into letter G. So this is G inverse of x equals this business right here. You could leave it like that, or theoretically you could put it on the common denominator for both of them. It's kind of up to you. In fact, I'll do both. I could leave it like this. This is perfectly acceptable. Or I'm going to, let me bring this up a little bit, give myself a little bit of space. Okay, and I'll do it over here. And this is going to be, so the common denominator is x minus 1. This is plus 1. It's really nice and easy. So this is minus 3 plus x minus 1, all divided by x minus 1. That's my common denominator. Hopefully you know, like that's an algebra or algebra 1 or pre-algebra skill. And what combines here is just this. So I could write this as x plus, or sorry, minus 4, all divided by x minus 1. Both of these are equivalent, even though they look a little different. This one's made out of two terms. This one is a rational, well, they're both rational functions, but that's just a different appearance. They are the same. Okay. And I think that is all for the basic demonstration of finding inverse functions. So I gave you a little bit of a variety, you know, like linear function, cubic, somewhere cubic, yeah, so cubic over here. This is fifth root, which results in fifth power. And lastly, a rational function. So I'm going to jump to something more advanced, even though you may not even be familiar with what this function is. In trigonometry, this is, you know, well, this is trigonometry. So in pre-calculus, you'll probably come across this. Definitely in calc, you'll come across this. And the idea there is, even if you don't know what sine function is, and you might have heard the term, but it really doesn't matter. The point is, this is still, I'm going to be able to invert it or find its inverse just by following the procedure. So what was the first step? Well, rename this into a y and switch the x and y positions. So this really is x on outside equals 4. Sine of what's inside here is y plus 2 and plus square root of 2. So even though, again, you may not even know what this is, but, you know, if you're in pre-calc, you might, you know, it depends when your teacher gets to the trigonometry. And I'm going to unwind things to get y by itself by normal inverse operations. In other words, subtract square root of 2, then divide it by 4, and so on. So this is going to be, on this side, this is going to be sine of something on the inside, which I can't, well, I know what's inside, y plus 2. But I can't really touch that. Yeah, until I do something kind of special about this. So what's over here? Well, I had x minus square root of 2 and the whole thing divided by 4. Okay, and there's my, because it's a 4 times. All right, now how do I get rid of sine in order to get rid of this so I can go inside here? Well, there's a sine inverse. You know, a sine inverse is an inverse of a sine function. And we write that by doing the operation called sine inverse of both sides. Now, I'm going to write it like this. And in this case, sine inverse and sine, they undo each other. You can sort of think of it as if they cancel. They like literally cancel each other. But they undo each other. And I think the next slide will actually talk about that a little more. Like when sine inverse and sine meet, well, what happens? Or a function and its inverse meet, what happens? So anyway, so what's left here is literally y plus 2 equals this complicated expression. Now, you may not, again, you may not even understand what this really means. It doesn't matter. I'm just going to write sine inverse. Sometimes in certain textbooks or certain teachers call it arc sine. That's fine. That's legit. But right now I'm not going to complicate things by using the word arc sine and written out. But anyway, sine inverse. And what's inside is x minus square root of 2 divided by 4. And then, of course, to get rid of this plus 2 by subtracting 2 from both sides. And it's gone from here. And there, and I'm going to rename it back into, what was it, f, I think it was, yeah. So this is f inverse of the original function. This refers back to like the original f, and the actual inverse itself, the function, is this. And again, you could probably make sense of it by seeing the similarities. We had a plus square root of 2 here. We have a minus square root of 2 here. Somewhere here we had a plus 2. Here's a minus 2. And there's a multiplied by 4. Here I have a divide by 4. And the most important one, of course, is here I have a sine, and here a sine inverse, because that's what undoes it. All right, so I think I'm going to try to finish this video. Well, I mean, the next example you could probably do yourself, even though it looks really complicated. You know what? I'll just do it. I'll just do it because they really are easy once you understand what the procedure is. So reversing the step, I'm just going to do my work over here. So this is going to be what out here, x, but then it's x minus that divided by this. So this is going to be x minus square root of 3 divided by 3. Oh, it's actually very similar to the other setup. Yeah, so you can just practice with this. So this is divided by 3 by this 3. And what do I need to get rid of? I need to get rid of the word tangent. So tan inverse of both sides. And then once I would do this, I can go inside. Oh my God, so I made it. So add pi over 2 to both sides. So I'm going to do a plus pi over 2. And then divided by that 2. So all of that divided by 2. So it looks a lot more complicated than it really is. And I'm going to rename this back to like the f function. So this is f inverse of x equals that, what looks to be like a mess, but it's really not that much more messy than the original, because the original looks like a mess. But once you get to pre-calc and calc, you'll see that this is really not that deep, not that difficult. Anyway, so that's the demonstrated procedure on a variety of functions. Now I want to talk about the important property of function and its inverses. And I don't know how much time, what this is. Well, maybe I think I'll leave the graphing part for next time. Yeah, because this really is like probably 2 full lessons in school with interaction with students. Anyway, so what's the important property of a function and its inverse? Well, the idea here is if a function, you start off with f of x, the input is x. Whatever you put in here, x, or you put a number, you put a 3 in here, and it does something. It does something to the to that input. Meanwhile, once you have an answer, then a function g function undoes everything you just did. So if you remember, one of the previous videos, or at least previous lesson, is when you have a composition function inside another function. So if you start with function and then you take the result of this, let me do a different color, the result of this, and you plug it into its inverse like this. So this, the answer from the original function, you plug into the inverse. They're going to undo each other. The f inverse and f will undo and give you back your original whatever you plugged in. So in this case, you plugged in letter x. This is your original input. And then because these two functions undo each other, you're going to get back to the original x. And we actually just saw that when these guys canceled each other out on, what was it, like when we had, let's say we have here a sine of 3x plus 1, right? So whatever that is, right? Like you don't know what that is, but it's something. If I do this sine inverse, they undo each other, leaving you with this is the answer. It's like square and square root. Now you have to be careful a little bit. You do. I mean, it's not there's because the words like is it going to be part of the domain and so forth. Uh, there's a little bit more to it than that. But as kind of like a first lesson, yeah, I think this is good enough. So the idea, like, how do I know if the two functions are inverses of each other? Well, you do a composition with them, and they should get back. So as an example, the question is f of x and some other function g of x inverses? Now, you could do it two ways. You could say if you're given an f function, you find its inverse, and you compare it to g and say, well, they're the same, so they must be inverse. Like, yes, that's true. But another way of doing it, and it's somewhat important. Well, it is important in calc. I mean, it's a deeper understanding. So if these two functions are inverses, then if I do this, and it doesn't matter which one I plug into which, I plug either f into g. So here I'll demonstrate both, kind of like this. This is a composition function, or I could do the other way. Into g function I plug this. Either way, if they are inverses, then I'm going to get back my original input letter x, whatever that is, just x. Literally, that's what it's going to work out to be. If they're in, so yes, if I'm going to get this, yes, they are inverses. But if I get anything else, it doesn't matter what it is, as long as it's not the same, x. As an example, if I get, 1/2 x or x plus 1, okay, and that will be a no, because they did not undo each other to the point of get back to the original question or the original input. Again, you'll see that through a demonstration. Okay, so again, I'm going to reemphasize this. It's pretty important that the two functions undo each other and give you back the original input. All right, let's jump and so the question, state if given functions are inverses. So the idea here, I'm going to take this, I'm going to do this, f, and into it I'm going to plug in g function, like this. And then if I get x, if I get this, then this is yes, they are inverses. If it's something else, then they're not inverses. So I'm going to take this function, and I'm going to plug it into whatever I see letter x right there. And simplify, do an algebraic simplification. So let's do it. So I'm going to take 4 times something, this complicated business, minus 20 divided by 5, and I am anticipating I'd like to get x back. If I get x by itself, if everything simplifies and cancels to become just x, then yes, they are inverses. Well, let's do it. Let's plug this into the letter x. So this is 20 plus 5x divided by 4. That's what this. And notice what happens right away. This 4 multiplies to this parenthesis, and the 4's cancel. Okay. And now that what's left? Well, you have 20 plus 5x, and then you have a minus 20, and the whole thing divided by 5. And of course, they're going to do what? The negative 20 and positive 20 cancel, and now 5x divided by 5 is x. So what I did, and in this case, what I did was I plugged g into f. So what I did was f(g) function from the previous video, previous lesson in class. You should know what this is. Anyway, so yeah, what happened here is everything simplified, and the 5's cancel, leaving you just x by itself. And so this is, yes, these two functions are inverses of each other, and you could sort of see that, it's not 100% where you could see through it, but this was a linear function. It's pretty simple. Let's do let me see if there's, let's do let's do this quick one right here. Okay, so I'm only concerned about the space. I'm also actually concerned about the time. Okay, so I kind of like do this, separate them. So here we go. I see. So which one does it make sense to plug things into what? Well, it doesn't. It really doesn't matter. The only reason where it may matter is like what's the easier step to begin with. And so in this case, let's plug f into g. Let's see what happens if I take this expression and I plug it into this x. Okay, so I have g on the outside, f of x, kind of like this. I'm not crazy about this blue color. I'm also not crazy about yellow. All right, anyway, so so the g function says take this big root sign, okay, cube root, and well, you have a negative, and then you have x. Well, so that means whatever you plug in, you plug in this in. I'm going to change the sign right away. So it's negative. Well, negative 2x cubed plus 2, kind of like this, and then plus 2 this one right here, and the whole thing divided by 2. And let's see if that simplifies. It looks messier than it really is. So the negative, so this becomes positive 2x cubed, but this part right here, this becomes minus a 2, so it becomes a negative 2. And I can actually see that this minus a 2 will cancel with this positive 2. Hopefully you're seeing what I'm pointing to. So right from here, I could say this 2 right here will cancel with this, even though it looks like a positive 2, but it is because it's negative 2 because of that. That's going to cancel. And what's left is this negative becomes a positive, and the 2 and this 2 will cancel. It really leaves you this x cubed on the inside with a 2 in front and divided by 2 and the whole thing cube root. And I could see that the whole thing will collapse to be the 2's cancel, x to the third, but cube root will be x. So yes, they are inverses. It looks uglier than it is. Now, you might say, well, wouldn't it be easier to simply take this function, find its inverse, and compare it to this? Absolutely. Yeah, you could have done that, and you'd see it's the same thing. Or take this function, find its inverse, and compare it to the f function. It would be equivalent. But it is an important property after all. You still want to be familiar with this f inverse of x. Of f of x. And it really doesn't matter what the order is. It could be this. You plug in one into the other one. It could also be written f o f inverse, like this, or reverse them. If they are inverses, then you're going to get back to letter x. And then it's an inverse. All right, so last example. Well, maybe last two examples, but okay. All right, let's. I'm going to plug this. I'm going to plug this into here and see if I'm going to get x by. So if I plug this in, basically what I'm doing into the f function, I'm plugging the g function. So this is like f o g. Okay, well, let's see. I take this, so I have a cube root, right? X gets replaced by x cubed minus 4. Well, there's a minus 4 there. Oh no, look, it's not going to cancel. Therefore, I know it's not going to. So if that had been a positive 4, or one of these positive, they would cancel, but here they don't cancel. And no, I do not get back to letter x. Therefore, this is a no. They are not inverses of each other. Okay. And let me see if there's, I don't, the other one, yeah, I could see this one's not an inverse. I can definitely see that that's not an inverse. And for one, if this is, 2 times x, I should be anticipating x divided by 2, or 1/2 times x. Yeah, these are not inverses, and you can prove it to yourself pretty easily. I'm going to leave it. I think I'm gonna stop right now. It's getting late, and let me see. And I think that's all I wanted to. Yeah, because this is a full lesson in itself, graphical, at least half a lesson maybe, graphical approach to inverses. All right, that finishes the topic of function, or at least the introduction, but a pretty thorough introduction to function inverses. And I will see you soon.